Anthony. How are you? Hello, Sperry. How are you doing? We're going to go over the final review today. Thank you. Good. We'll start in a couple minutes. Hi, everyone. How are you doing? If we get everything done today, this is going to be the last session. But if we don't, then we'll meet up again on Thursday. But so hopefully I'll be able to get everything done. Check out your final review part 1. That's what we will start first. Hi, Beethoven. I'm good. Thank you. Okay, so we're going to go ahead and get started. So today, my goal is to finish the final review part 1 and 2. But if I don't get to finish part 1 and 2, then we will have to wrap up the rest on Thursday. I'm going to go ahead and screen share real quick. Let me get to the modules. So for your final review, you will find your final review here. This is in Canvas and it is after unit 12. As far as last week, we don't have any more new concept to cover. We pretty much cover everything that's required in the class. But also remember that you do have a quiz this week. This is our last quiz, quiz 3. That's going to cover chapter 5, 12, 13, and 16. There is an extra credit opportunity for the review game. So don't forget to do that. If I finish all the final review this week, you will not have to meet on Zoom next week. So I'll give you time to work on your project. Don't forget that you have 2 additional parts. If you haven't signed up for the project, make sure you do so. I did give you the credit for signing up for those of you who've done that. And then work on your programming, your documentation, self-evaluation, and you don't need to do an e-portfolio. You simply just do a GitHub, okay? So those are the things that's needed. On the final week, you will be given a multiple choice final exam. That's going to be 50 questions. And you are going to use Lockdown Browser. I will turn this on next week so you can have time to install your Lockdown Browser. And you will need to use it to take the test. The test is also password protected. So I will turn on the test during week 16, which starting on the 12th. So I'll turn it on that Monday, and then you'll have until Thursday to complete your exam. So you have a few days to work on it, but do not wait till the last minute because the exam closed and I don't allow late exam. Okay. All right. So let's take a look at your final review part 1, and you can find this right here. So the final exam is going to cover everything from the beginning to the end of the course. So the first part of the final exam, you've seen this in our quiz and our assignments. You will need to do the conversion. Now, on Lockdown Browser, you will be able to use Scientific Calculator. It will not permit you to use Programming Calculator from Windows. Lockdown Browser does have their own calculator. So you will not be able to use programming mode on the actual computer that you're using for your exam, okay? So you will see a question like this. And the first question asks you to convert decimal value 147 to binary. And it's gonna give you the details: byte, word, bits, double word, and quad word. So just keep in mind that a byte is 8 bits. So if I want the answer in 8 bits, I would say that the result should be in a byte, and that will be 8 bits, okay? And then the word will be 16 bits, double word is 32 bits, and quad word is 64 bits. So as we go through, we are going to take this decimal. We're going to use the decimal equivalent scale, which is always the same, starting from the right, going left, multiple by 2. So 1 times 2, 2 times 2, and so on. And so we are going to take 147 and we're going to subtract the largest number on that scale. So that will be 128. So as you subtract it, you can put a 1 on top. You would have 19 remain after the subtraction. Then you go down that scale and look for the number that you can subtract next. That will be 16, because 32 is higher and 64 is higher than 19. So you would take 19, subtract 16, you would have 3 left. And then that means that we can subtract 2 and 1. So 3 subtract 2. And as you subtract it, you put a 1 on top, and then so on. Okay, so when we get to the end, we will have 0 remain. Now, this is a subtraction method. You can definitely use the division method, where you would take 147 divided by 2. And then if you have the remainder, if you don't have a remainder, you want to make a note of that. And we went over that during week 1. So this is how we would convert decimal to a binary value. And so the ones that you don't subtract, you put the 0 in, and the result is this. Okay. For number 2, we're going to go the other way, where we're going to make the binary into a decimal. So again, we can use our multiple of 2 scales, which is 2 to the n, starting from the right, which is your least significant bit. And you would put the 1s and the 0 on top of that scale. Then you're gonna add up all the ones. So I start with 128. That bit is on. Then I would skip 64 because that's off, this right here. Then the next one is 32. I add that. Then I would add 8, 4, and 2. Those are the bits that are on. So as the bits that are on, you add them up, and I highlighted those for you. We would have 174 in decimal, which is base 10. And so when we go to from binary to decimal, we would do the addition method. When we go from decimal to binary, we can use the division method or the subtraction method. So you will see questions like that on the exam. Then you will also be given questions for hexadecimal to decimal conversion. So our decimal to hexadecimal scale is that when the number is 0 through 9, in decimal, that will be equivalent to hexadecimal 0 through 9. Then you have A is going to be 10, B is going to be 11, and C is 12, D is 13, and so on. So it ends at F because hexadecimal has 16 number from 0 through 15. So now you can use two methods to do this. You can use each of the hexadecimal value. We can make that into a 4-bit and then convert it to binary and then decimal, or you can use the multiplication method. So I first would write out my hexadecimal equivalent. So a C, we know that a C is 12. So that will be 12. And so let's start again. Let's start from the right. We would start with the 2. We would multiply it by 16 to the 0 power because that's the least significant bit. Then we would add it to the next character or the next digit, which is F. And F is 15 in decimal. So you would take 15 times 16 to the first. And as you move left, you would raise the exponent by 1. And then the next digit is 3. And 3 is 3 in decimal. So 3 in hexadecimal, we would multiply it by 16 to the second. And again, we raise the exponent. And then we'll add it to the next digit, which is C, or 12. And we would multiply it by 16 to the third. So once you multiply everything out and add them up, you would have 50,162 in decimal for C3F2. We would need to know how to do addition and subtraction in binary. And remember, we talk about how to use carry and borrow. So as you subtract, make sure that you follow the borrowing. When you carry it from one column to the left, that's when you borrow. So 0 subtract 1, right? We would borrow, and so on, and handle 2 level at a time. So when you line them up, when you subtract, just make sure that you handle the top and the next level, and then have the borrow and then handle those with the below line. So the result for number 4 is 10001111. Then for number 5, we would do the addition. And again, make sure that we remember how to use the carry when you have a 1 plus a 1. And don't forget about subtraction and addition rules. That was in chapter 1 or unit 1 notes. So when we add these two binary together, we would have the result of this. Then next is number 6. We would convert decimal value to hexadecimal number. So earlier we went from hexadecimal to decimal, we would multiply in number 3. Now we would go the opposite way. So when we use decimal value and convert it to hexadecimal, we would divide. So you would take 402 divided by 16. You have 25 as a quotient, 2 as a remainder. And we want to make note of the remainder because that's going to be our result. Then the quotient 25, we would continue to divide that by 16. We would get 1 as a quotient and 9 as a remainder. Then we still have 1, so we have to keep going until we get 0. So 1 divided by 16, we would get 0 as a quotient and 1 as a remainder. So as you write out your value, you would have the first division line that will be the least significant bit. So that will be 2 on the right. That's the first remainder. The next remainder is 9. So you put that next to the 2. And then the last remainder is 1. So you put that in front of the 9. And we will put the base 16 because that's hexadecimal value. So the result for number 6 is 192 in hexadecimal. And we simply use the division method there. Any question? Okay, so easy, right? We have done this before. For number 7, we need to do the 2's complement. Okay, so the first one, 7a, we are given a decimal value, 567. The easiest way to do this, right, is to make it into binary first. So convert the decimal value 567 to binary. And you can use the subtraction method or the division method, that's your choice. So once I have the binary, I would not the entire binary or flip the bits. So the 1's become the 0 and the 0 becomes the 1. So that will be the 1's complement when you flip the bits. Then after that, we would continue to the 2's complement where we would take the 1's complement and we would add it with a 1. And that is used for sign, right? That 1 bit that goes in the front, that would be sign. So as you operate the addition, you would see a bunch of 1's in the front, right? So this is a representation in binary for -567. That will be a 2's complement. So likely that on the test, you will find the answer in binary, right? Because it's obvious, it's -567 is the 2's complement of 567. For 7b, easier, we're given a binary, so we can go straight into the 1's complement by not the binary value or flip the bits. So the 0 in the front becomes the 1, the 1's become the 0. That will give us the 1's complement. Then we simply add a 1 to make it a 2's complement. So we would take that binary from the 1's complement plus 1. And so we would get this. Now you notice that I placed the ones in the front, right, to fill up the word, because these ones just represent the sign in the front. Okay. So in the question, it will tell you how the answer should be expressed, whether in a byte, which is 8 bits, or a word, a double word, or a quad word. Usually just byte or word or double word. Not too lengthy. Then for C, we have a hexadecimal B93. And the way that I did this was I took each of the digit for the hex and I convert it into a 4 binary bit. So we know a B is 11 in decimal, and you simply convert 11 decimal into a binary. So I got 1011 for 11. 9 is a 9 in decimal, so we simply convert a 9 into binary. So that will be 1001. And then a 3, same again, we simply convert that. So each hexadecimal digit is a 4-bit in binary. So I write them together. Then I can go into the ones complement by flipping the bits or not the binary. So I would get this. Then I would have the twos complement by adding the 1. So that will be the result. So a sign B93 hexadecimal is this in binary. Skip D. So if you know how to do C, you should be able to do that. So don't worry about that. Okay. Question 8. I think I scrolled down too far. Some of you might be still putting together your answer. Okay. So we are going to use the logical operator with the given values for number 8, A, B, and C. So make sure that we know how to use and, or, not, nor, right? Nan. So a nan is a not and. So you and it and then you not it, right? A nor is a not or, so you or it and then you not it. So make sure that we know how to apply the logical operator at binary level. So for number 8, we are gonna take the 2 binary values and we're gonna AND them. Remember, AND, anytime you have a 0 in the mix, it is a 0 as the result. And the easiest way to kind of remember this is think about like the if statement when you use the AND operator, right? When you have the if, this, and this, they both have to be true in order to be true. So if you have a false in there, it's not going to execute. So you would have 0 and a 1 is a 0, 0 and a 1 is a 0, a 1 and a 1 is a 1, and so on. So make sure we remember the rules. Then for the OR, so for A, this is the output when we AND these together. For 8B, we're going to OR them. So we are given this value and this value. So you can line them up and you would OR. So for OR, anytime that you have a 1, you have a 1 as an output. So a 1, a 0 or a 1, we get a 1. A 1 or a 0, we get a 1, and so on. So the result for B is this. Now for C, we are given a binary and we have to apply the not operator, which is a unary operator. We simply flip the bits, or we can say 0 becomes 1 and 1 becomes 0. Now, the question tells you that this needs to be expressed in 16 bits or a word size. So that's like standard for most systems. In some newer system, a word size is larger. So once we flip the bits, because it's only 13 bits here as our answer, we're gonna fill in the rest. So we have to put the ones in the front to carry the sign. Okay, any question? All right. 9 goes over the Boolean expression used in disjunctive normal form. So make sure we know the difference between conjunctive normal form and disjunctive normal form. So for the D and F, the form of it is that we would take one term and we would OR it with another term. And inside the term, we would have the AND. So you would have A and B or C and D. Sometimes in the term, you might have a not, but ultimately when you connect the terms together, for the D and F, you would use the OR. Whereas C and F, you would use the AND operator. So make sure that we know the rules for Boolean expression for D and F. That will be variables within the term would be AND together. We see that inside the term here. The terms are OR together, so we would connect the terms by the OR. And when you see the symbol in the front like this, that means that it would be represented as a not, right? Sometimes that can also be used as it is also an operator. Okay. And then on the outside, we don't need to apply the parentheses. Any question with 9? Okay. You've seen this in your assignment. 10, it gives you a set 2, 4, 6, 8, 10, 12, 14, 16, and 18. Here is your set S. And it asks for the cardinality of the set, which is the number of elements in that set. So you simply count them up. You should get 9 elements. And that is denoted as this: pipe, S, pipe, and then 9. That means that the size of that set is 9 elements, like using size of in the array STL, right? Set actually has its own STL in C++. And for 11, we would denote an empty set by a 0 slash to it, or a set of curly braces with nothing inside. So make sure that we know how to notate, use set notation for our final. Any question? Okay. All right. For number 12, we are going to compare set X and set Y to see if they are equal. And it's pretty easy. So you start with looking at its cardinality, right? Cardinality for each of the set. How many elements are there in that set? So here we have 5. The other ones also have 5. Then we would match up to see if each of the elements are equal. So we can conclude that X and Y are equal because they contain the same number of elements and the same elements. Then for 13, we again would compare set A, B, and C. So we were given the values and they don't have to be in order. Just keep in mind that set you don't repeat. The numbers are the same. So if you have 2 10s, you only put it once. Okay. So first we would look at the number of elements for each of the set. So on A, we have 3, 5, 7. And then B, we have 6. And then for C, we have 7. Then we can compare the values in the elements. They all have -2. The first two have 82, but not C. So we can quickly say that first, they are not equal because they have different number of elements, A and B, right? And then also they don't have the same values. So we can say that A is not equal to B or C as they contain different values or elements. And B is not equal to C for the same reason. Then for 14, we would look at y squared is less than 20 for the set 5, 6, 7, 8, 9, 10, and so on through 16, except for it doesn't have 15. So we want to express this using notation. So we can say that y is an element of the natural number. That's here in the question. Y squared is less than 20. So that would only apply to, given that, right, for y is we can say that when we square 25, right, y has to be actually, it cannot be anything in this set. Because if you square 5, you would get 25. You square 6, you get 36, and so on, which is not less than 20. So that means that y has to be less than 5. We can say y must be less than, oops. Then in 15, we're given T is 2, 4, U is 6, 8, and W is 1, 3. we are to determine the Cartesian products of T times U times W. So you simply start with the first value and you would match them up across, right? So 2 and 6, 2 and 1. So I start with the first, go to the next first, then here and 1. Then I go to the second value, so 2 and 8, 2 and 3. Then I move over to the second number, which is 4, 4 and 8, 4 and 3. And then you can do like 6 and 1, and then 6 and 3, and so on. So based on the power set theory, we should know how many we would be getting for Cartesian. Okay. Then for 16, we are going to explain the relationship between A and B. So A is here and set B is here. So you are going to be given Venn diagrams and you have to select the choice that best express that Venn diagram on the exam. So we know that B is a subset of A based on the Venn diagram. That means that it could be included in A. For every element of A could be part of B. So the way that we write the subset is this, the C with the line underneath. So we would represent B as a subset if B is a subset of A. In this case, B might be equal to A. Then we can say that B is a set of A, and that could be a subset of A, and A is not equal to B. That means that A might have more elements. And so every element of A is an element of B, but at least one element of B that is not an element of A. So that means that B is a proper subset of A. So make sure we understand how to interpret Venn diagram and know how to explain subsets. Then we will look at intersection and union. So for number 17, we have R, S, and T, given the sets here. And first, we're going to look at the intersection between R and S. So those will be the values that would be the same in both sets. 10 and 15 shows up in both sets. So that will be the intersection. For B, we would look at S and T, and we would find the intersection with S and T. So 15 shows up there, 25 and 35, all three come up in both sets. So that will be the intersection for B. Then for 17C, we want to look at the intersection of R and T. So we simply look at R set and T set and find the number that shows up in both. So we can see 15 and 60 show up in both. So the upside down U is the intersection. Make sure we know that symbol. And then also make sure you know union as well, right? 18. We're given set D, E, and F. We have to look at symmetric difference across these sets. So when we look at symmetric difference, we would look at how one set is compared to the other and the values that is absent in the other set, we would include those. So when we look at D is symmetrically different than E, we would have 1 in D but not in E. So we put 1, 2 in E but not in D, we put 2, and so on. So the values that are absent in the other set, we would note those for symmetric difference. And we would use the delta symbol. And for 18b, we would do the same when we compare E to F. What is in E and not in F, and what is in F and not in E for symmetric difference. So we would have 2, 3, 6, 10, and 12. Any question? Let me move this up. Then for 19, it goes over power sets. So P of S, given S is 2, 3, 4. And that's easy. You only have 3 elements. So you would take 2, raise it to the third power. You should have 8 subsets. So we would start with the first subset that will be empty set. Then we would have subsets of 1 element, 2, 3, and 4. Then we would have subsets of 2 elements, 2, 3, 2, 4, 3, 4. And then lastly, we would have subsets of 3 elements. So when you count them up, 1, 2, 3, 4, 5, 6, 7, 8, you should have 8 subsets. And if you take 2, raise it to the third power, why third power? Because there are only 3 elements in the original set. So we would have 8 subsets for 19. Then we also went over combinatorics after we cover sets. And make sure we know the definition for our sum and product rules in combinatoric. So sum rule is applicable when you make one choice from the union of 2 or more alternatives. Like when we select, right, a dessert or an appetizer. So you can only select one item from the dessert group, right, and the appetizer. Now for the product rule, that would be applicable when you make two or more consecutive choices, like you would choose soup and sandwiches. Then for 22, this is an example that we've used also in our assignment. This talks about combination padlock where you use three numbers, 0 to 40. And it asks you for the how many combinations of the numbers you can use. So first we set up our cardinality. 0 through 40 gives us 41 numbers. And since we're using 3 digits for our padlock, that will be 41 to the third. And in this one, we apply the product rule as you take 41 times 41 times 41, which gives you 68,921 ways that you can come up with 3-digit combination for your padlock. And we say combination because we reuse the numbers, right? For 23, there are 3 groups of audience: 30 people group 1, 40 people group 2, and 50 people group 3. We want to find A, how many distinct ways can a person be selected from all 3 groups? So when you see that, you would say sum. So we would take 30 plus 40 plus 50 gives us 120. So there are 120 ways to select a person from all 3 groups. Then for B, how many distinct ways can we select a person from each group to meet the performer? We would use the product rule. 30 times 40 times 50 gives you 60,000. Then for C, how many distinct ways can 5 people be selected from group 3 to win tickets? Then for group 3, we know that there are 50 people. So here we would use permutation. 50 times 49 times 48 times 47 times 46, which gives you 254,251,200 ways to select 5 people from the group. And as we select the people, right, we don't reuse those people, we remove them from the group. So this is where we would see that it is permutate. And we stop at 46 because that would give us our 5 people from 50 down to 46. So you will see questions like this on the test. Just pay attention to how it's asked. And you would apply the sum or the product rule or permutation accordingly. Then for 23D, how many distinct ways can 5 people be selected from all the groups to win backstage passes? Again, we would apply the product rule. Since there are 120 people in all 3 groups, we would then take 120 times 119 times 118 times 117 times 116. That gives us 5 people. And that when you multiply everything out, you would get the number of variations that we can form 5 people from all the groups. Any question? So final exam is very much like the quiz. It's going to focus more on the mathematics side, where your project is going to show me your programming skills, how you apply discrete structure concept in programming. Let me move this up. Make sure we know the definition for permutation, which is an ordered arrangement of a set or a subset of objects. So order matters. So for question 25, it asks you there are 32 students in discrete structure class. Course project requires 4 students per group. How many variations of the groups can be performed for the project? Can be formed for the project. So we can use the twos equation here. So make sure we remember how to do that. So first, we would take the number of people, which is n, and we would take a factorial of that. Then we would divide it by, and when you use the calculator, make sure that we use the parentheses accordingly. We would take the r, which is the number of people that we're choosing, and take a factorial of that, multiply it by n minus r factorial. So we would get 35,960 students, or 60 ways we can form 4 student group in the class. We saw this question before in our assignment. A toddler chooses 3 toys from the box, which contains 12. How many variations of toys can this toddler choose? So again, we would apply the equation or the formula, n factorial divided by r factorial times n minus r factorial. Plug the number in, and we would have 220 ways to choose 3 toys from the box of 12 toys. Any question with these? You've seen them before. So on the test, they will not be this exact question, of course, right? You would get something close to it. 27, first grade teacher needs to select 4 boys, 4 girls, for 4 boys and 4 girls for the talent show in a class of 20 students, 10 boys and 10 girls. How many ways can a teacher select the students? So first we can just take the group of either 4 boys or 4 girls and trying to find the variations of boys or girls selection. So we choose 4 out of 10, apply the equation. I didn't multiply everything out. You can do that. So 10 factorial divided by 4 factorial times 10 minus 4 factorial. That will give you the variation of boys or the girl selection. After you get the result for that, then you would take it and multiply it by itself. So you would get the variations for boys and girls, because boys and girls numbers are the same. So on number 28, we need to know how to use binomial theorem, applying that to what we learned with the choice equation, right, for permutation. So we would start with, for 28a, a plus b to the 5th, right? We start with choosing 0b and all 5 a's. And then as we move right, we would increase the b and reduce the a in exponent. And so you would have the result as shown there. And keep in mind that we didn't put in the quotient because it actually comes from Pascal triangle, right? So we would then look at the exponent here and then use Pascal triangle. For 28b, same thing. We would then now have exponent 8. So you would start with choosing 0q and 8k, and then we would expand it as we go right. We reduce the first variable exponent and increase the second variable exponent by 1. Any question with these? Okay, next is going to be our probability section. And remember the dice, right? So for the test, you might be given questions that ask about sample space or the probability of rolling a certain number on the dice. What's standard phase? 6. So for the pair of dice, we know that it has 6 space each. So our sample space, we use the product rule here. So 6 times 6 gives us 36. So you always want to start with the sample space first. Then you can go into probability. So if I need to roll a sum of 7 for both dice, then I can do a 1 and a 6, a 2 and a 5, 3 and a 4, 4 and a 3, 5 and a 2, and a 6 and a 1. That gives me 6 combinations. Then I would take 6 divided by 36, which gives me 1 over 6 or 0.667. So for the answer for the test, the choices that you're going to get is going to be fraction or decimal. And so I do allow scientific calculator, so you should be able to calculate that. Then if we want to find the probability of rolling the result of a pair of 6, right? Both faces have to be 6. There's only one pair, so that will be 1 over 36. So any of your pair will be 1 over 36, right? A pair of 2s, that would be 1 over 36. A pair of 5s, that would be 1 over 36. So if you forgot how to do this, make sure you check out the unit that we went over, probability. That will be after combinatorics. 30 is on deck of cards, which is 52 cards. And we want to find a probability for various criteria. A, the card is a queen. We know that there are 4 queens in the deck: heart, diamond, spade, and club. So 4 divided by 52, that will give you the probability of getting a queen from that deck. Then for B, if the card is a red face card, right, there are 2 suits that are red and 2 suits that are black. That means 50 right, are red and 50 are black. But it tells you a red face card. So a face card would be Jack, Queen, and King. So if you look at that, you would say there are Jack, Queen, and King diamonds, and there are Jack, Queen, and King hearts. So that makes it 6 face cards that are red. So 6 divided by 52 is going to be the probability of getting red face card. Then we would look at the card that have the same suit. So there are 13 cards in a deck, in a suit, in a deck, right? If you start with A's as lowest or could be highest, right? So that would be 1 through 10, and then you got the face cards, which are 3 more. So you have 13, that will be 13 divided by 52. Then if I want a card that has to be an even number, right, like 2, 4, 6, 8, and so on. So if I look at that, right, I would have 2, 4, 6, 8, 10, 5 per suit. We have 4 suits, so you take 5 times 4, then you would have 20. And take 20 divided by 52, that will give you the probability of getting an even card in a deck of 52. Any questions on probability? Okay. So the purpose of this is to just jog your memory, and if you miss anything, you can ask. Okay. All right. Next on drawing balls from the bag, we have 10 balls, number 1 through 10. And we need to draw the numbers 9, 5, and 2. You've seen this already in 3 draws if the ball is returned to the bag for the next selection. So we're reusing the balls. So we would have 6 successful outcomes in the combinations of 952, 925, etc. And since there are 10 balls, we are doing 3 draws. We would take 10 and raise it to the 3rd power, which gives us 1,000 possible outcomes. So we would take 6 successful outcomes divided by our sample space, which is 1,000, giving us 3 over 500 for the probability. Then for 31B, we would look at the same scenario. We have 10 balls. We are drawing number 9, 5, and 2 in 3 draws, but we're not returning the ball into the bag after each selection. So we know that we have 6 successful outcome from the prior question. But since we're not returning the balls to the bag, right, our sample space would be lessened. So that will be 720. Okay. Why 720? 10 times 9 times 8, right? As we remove each ball each time we draw. So your probability would be 6 over 720 or 1 over 120. And then for C, if we need to just draw the ball 8 and in 3 draws and we're not returning the ball back to the bag, then you would have 720 possible outcomes, or your sample space is 720. So 10 times 9 times 8. And this is where we would use inclusion-exclusion principle. So we know that there are 9 times 8 times 7, which is 504 possible outcomes that do not include the number 8. That leaves the difference. So we would take 720, subtract 504, giving you 216 outcomes that includes ball 8. And so the probability of that would be 216 divided by 720, or 310. So make sure we understand how to use inclusion-exclusion principle here. I'll leave it there for a second. Question. Let me move this up a little. I don't know why it drops. Okay, 32. Use inclusion-exclusion principle to determine how many positive integers between 100 to 987 are inclusive. So you simply take 987, subtract 100, because that's the range given to us in the question. And then you do a +1, which gives you 888. How many positive integers between 100 and 988 are divisible by 8? So every 8th digit is divisible by 8. So you take 888 divided by 8 gives you 111. Then for 32b, how many positive integers between 100 and 987 are even? So every other number is even. So you would take 888 divided by 2, which gives you 444. Then for 32c, how many positive integers between 100 and 987 are distinct digits? That means that the digits are different from left to right. So they all have 3 digits. The leftmost digit cannot be 0 because it starts at 100. So there are 9 choices. The second digit can be any digit but the first. So that would be also 9 choices. And then on the third digit, would be 8 choices because it cannot repeat the first and the second. So then you would take 9 times 9 times 8, which gives you 648 distinct digits. And so if we have 1,000 between 900 and 879, for example, you just be able to calculate that with the 4 digits or bigger digits, right? Question. And then after this will be Pascal, and we'll move on to part 2 and then finish that, and we will be able to wrap up everything. Then you would have Thursday off and next week off. No Zoom. Now, if you need help or have questions, things like that, message me and then I'll hop on Zoom. Okay. Okay. I'm going to move to the next page now as it's going to cut off for Pascal. So make sure we know how to use Pascal. And so for the question here, 2y squared plus 5z to the third, and we would raise everything to the 4th power. So when you look at the Pascal triangle, we talked about patterns and how there's certain things that repeat when you're looking at, you know, a certain from diagonally a certain way. So for the 4th power, that will be here. So your first quotient for that will be 1, just the first number here. The second will be 4. I highlighted that. Next will be 6. Next will be 4. And next will be 1. And so I simply expand it with binomial theorem, right? As I move to the right, I would increase the y, I'm sorry, increase the z and decrease the y. Now this one's tricky is because they are together. So make sure that you also raise the value in the front here too. Okay. Any question on this? So for the test, you will have questions on binomial and Pascal, and it would ask you what would be the result of this. And so you just want to make sure that you select the right choice. And final exam is 200 points. That means that each question is worth 4 points. Okay. Let's move up. So for 34, we wanted to understand the difference between unordered and ordered linear search. So ordered, we know that it is pre-sorted, where unordered, there's no sort to start. And in the worst case scenario for the unordered linear search, it would go through the entire collection or the container, right? So it has to go through the entire collection in the case it cannot find that object. In the ordered linear search, since it's pre-sorted, the search can be terminating early when it's determined whether that number is sought. Okay, so here it says that the number that's being sought, if it's found, then it terminates early, which is less than the number of element that's currently being examined. For 35, we want to know the steps to solve problem using algorithm. The first step is to design a step-by-step procedure to solve the problem. So as you start your project, you need to think about that. Design your algorithm. Second, we would analyze the correctness and efficiency procedure. We've done that in the lab many weeks, including the last one when we did the cryptography, right? We looked at some program that worked and some program that didn't work, some program that's more efficient than the other. Then we would then implement the procedure in a programming language like C++. Then we would test it. Now, depending when you get more into software engineering or software development, they'll talk about whether you wanted to use waterfall or agile approach, right? Waterfall is when we would go all the way to the testing, and if it fails, then we start all over again with redesign, analysis, implementing, test again, right? Whereas agile, you would design and test in the same phase. And that will be end of part 1. We'll start with part 2. So as you finish this, do not forget to submit. I do give you like 2 weeks from now to be able to submit it, but don't forget, because the 0 comes in and then it will take an impact on your grade, where this should be freebie, right? Okay. Any question on part 1, final review? No question. Okay. Let's take care of part 2. So let's download part 2. And you can find part 2 right below part 1. Also, I want to remind everyone, if you do have missing assignment, they need to come in by the 5th of December. I will have a cutoff where I need to finalize your grade. I did update your grade recently. So if you had something missing or you're still working on it, for some reason, if it's locked, email me and I'll unlock those for you. Okay. All right. labs, assignments, anything that you miss, you need to turn them in before the 5th. Okay, part 2, chapters 9 through 17. We did something similar already for this part, but I'll go over it again. Okay. Number 1 for part 2, final review, 10 balls, number 1 through 10. We want to draw a number 8 ball on one single draw. So we know that our sample space is 10 because there are 10 balls in the bag, and we are going to get one ball. So your probability is 1/10. And if we need to draw an 8 ball where the ball is not returned to the bag for the next selection in 3 draws, then we need to look at the sample space like what we talked about before. 10 times 9 times 8 gives you 720 possible outcomes. And you would have 504 that do not include the 8. We saw this in the prior question. I just repeated it. I should take that out. That leaves 720, subtract 504, which gives you 216. So you take 216 divided by 720, which gives you 310 for the probability. And for B, the probability of drawing ball number 8 in 3 draws if the ball is returned to the bag. So we know our sample space is 10 to the 3rd, which is 1,000. And we know that there are 729 outcomes that do not include the 8. So that means that when you remove the 8, you only have 9 balls for the 3 draws. So 9 to the 3rd, which gives you 729 here. So when we take 1,000, subtract 729, that will leave you 271 that would contain the 8. So the probability of that will be 271 divided by 1,000. And for C, you can put same as A. It's repeated. My boo-boo. And then for D, to draw number 952, we've seen this from part 1. In 3 draws, if the balls are returned to the bag. So you have 6 successful outcomes for those 3 numbers out of 1,000 because we're reusing the ball. So it's 10 to the 3rd. So that means we take 6 divided by 1,000, which gives you 3/500 for the probability for 1D. Any questions on these? All right. And then for E, the probability for 952 if the balls are not returned to the bag. So we would have 6 successful outcome of 720. So take 6 divided by 720, or we would get 1/120. You don't have to write down all the explanation. If it helps you keep notes and for your review purposes, you can just type down the answer. That will be fine for the assignment submission. So for question 2 in review part 2, when searching 2000 elements in a vector, assuming that the system takes 0.5 nanosecond to search through each element, how long does it take for the entire vector? So if we use linear, then we would take 0.5 nano times 2000, which gives us 1000 nanoseconds. And we can convert that to minutes and hours and so on if we like, but the answer like that will be okay. Okay, for 3, in application that uses chunk search, if an application that uses chunk search, it needs to find a match in 100 elements in the array, what is the chunk size? So take the number of elements, take a square root of that, which gives you 10 elements per chunk, and there are 10 chunks. So for the final, there will be questions on linear, chunk search, and other type of searches as we binary search here. Okay. When searching an array of 8,400 elements, how many comparisons must be performed for the binary result? So we would take natural log of the number of elements, which is 8,400, divided by natural log of 2, as it is log 2 of n, right? So we would have approximately 13 comparisons for the binary search. If we use chunk search, we would take square root of 84, which gives us 91 elements per chunk. And so we would take 91, we multiply it by 2, because it's 2 times square root of n is the number of comparison for chunk search. So you would end up with 182 comparison for the chunk search when we use 8,400 elements in the container. And then linear search is the easiest. It is the number of elements as it would seek through all the elements in the worst case scenario. So 8,400 for 4C. Question 5. You're given the data below. Explain how insertion sort can be used in the given data. So the first step for the insertion sort, it would take the first 2 values in the container and it would compare which one is smaller. If 6 is, because 6 is smaller than 87, it would move 6 to the first place. And we talked about how we would do a triangular move, right, in programming, because there's no magic empty space where you would put that in. So 6 is less, put that in the front, and then it would compare 14 to 6 and 87. So since 14 is higher than 6, it puts it after the 6, it inserts it after the 6 and before the 87, and so on. So make sure we know insertion sort. and different sort mechanism. For question 6, it gives you a set S, which is 13, 16, and 19. This is the sequence. So we want to represent the sequence using an equation. So the next value in that, we know that 13 plus 3 gives you 16, and 16 plus 3 gives you 19. So therefore, the distance between one element and the next element is 3. We would do a constant 3. So then we would take 19 plus 3, which gives us 22. That's the next term in S. And we would use arithmetic progression equation. So we would have T of n is equal to 3 times n plus 10. And when we test that with the first element, we would take 3 times 1 plus 10 equals to 13. So make sure we know how to use arithmetic progression formula. Then 7 is very easy. It gives you T of n is 5 times n minus 2. Then you have to come up with the sequence. So we simply plug in n, where n is 1. 5 times 1 minus 2 is 3. N is 2. 5 times 2 minus 2 is 8. N is 3. 5 times 3 minus 2 is 13, and so on. So we would have a partial sequence, 3, 8, 13, 18, and etc. So I think I skip a number. It would be like 9 on yours. Okay, select the option that represents a quadratic sequence. So you would have option A, 3 times n squared plus 6n plus 1. B is n minus 4. That's definitely not a quadratic. C is not a quadratic, right? So the easiest way to determine which one's quadratic is in quadratic format, right? So you would have the variable raise it to the square power plus or subtract, right? Another variable and then plus C. So use the quadratic format to determine what the quadratic sequence would look like. So A and D would represent quadratic sequence as it is in quadratic format. Now for the test, there will only be one answer. Okay, I am not cool and unusual. I don't like multiple answers because I hate those. I think that just increased the probability of you getting it wrong. So just gonna be one correct answer. Now for quiz games, sometimes I would do multiple answers because it's fun, but for grades, it's usually just one answer. All right, number 10. Determine the recursive formula for following quadratic sequence 4, 8, 11, 13, and 14. So in this, right, we would start with finding the first level of difference by subtracting the next value to the previous. So 8 minus 4, we get a 4. 11 minus 8, we would get a 3. 13 minus 11, we would get a 2. And then 14 minus 13, we would get a 1. So once you found the first level of difference, you would then have a second level of difference by taking the difference of the first level of difference. So 4 minus 3, you get a 1, and so on. So in quadratic sequence, you can see that the difference is an arithmetic progression. Okay. For the second level, and then the difference is a progression. So it is a constant for the second level of difference. So we would use this equation for quadratic. A times n squared plus b times n plus c. And then we plug a in and b in and c with n. So n is, we would use 4. So 4 is a of n. A times n squared, which is 1 for the first value here, plus b times n, which is 1 plus c. So I would have the equation. Then I plug in a, again using this formula. So a is equal to a times n, which is 2 squared, plus b times n plus c. So plug in n and a of n. So the result of that would be, let me tap this in. That will be a equal to 4a plus 2b plus c. Then I plug in 11 and n is 3. So I would have 11 equal to 9a plus 3b plus c. Then we would take the difference. We've done this before, right? We practiced this. So you would take this one and you would find the difference with this one. Okay. So 4a plus 2b plus c, that's this, minus a plus b plus c equal to 4. Then you got the result. Just line them up and subtract. Then you would take the next one, which is this. Subtract the second. Which you have 5a plus b equal to 3. And again, we would line them up and subtract. Then after that, we would find the difference, the second level of difference between those, and we would come down to a single variable. We solve for that variable, plug it back in, solve for the next variable, plug it back in, solve for the third variable, and we would have the result. And this is only one way to do it. There are other ways to solve for quadratic. So if you know the other ways, you can use that. So I would then subtract the 2 from the first level of difference. and I'm down to a single variable, which is a. So I have 2a is equal to -1, where we would have, we solve for a by dividing by 2 on both sides, so we would have -1/2 for a. Then I plug it back in, right? To 4 minus 3a, which is this right here, to solve for b. Let me rewrite that. 3 times 1/2 plus b equal to 4. So algebraically, we can solve for b. And then after that, we would have b is 11/2. Then we can plug everything back into a, b, and c. So a plus b plus c is equal to 4. You already have a, you already have b. Now you can solve for c. So once we plug a for -1/2 plus b is 11/2 plus c equal to 4, c is going to be -1. Then we come back to our quadratic equation and we plug a, b, and c in. So we would say that a of n is equal to -1/2 times n squared plus 11/2 times n minus 1. And this is your answer. Make sure we know how to do this. And when we find the level of difference first to second, simply we were able to solve for a when we get to second level of difference. And if you learn additional theory, you would be able to see it already in the table. Okay. Eleven is Gauss-Trick formula. Make sure we know Gauss-Trick formula to find your series or partial sum. So we would take the first number plus the last number, multiply it by the number of term divided by 2. So I'm given this sequence. And since it's arithmetic sequence, I'm able to find the sum using Gauss-Trick. So we have 6 terms. So 6 divided by 2 times -72, which is the first, plus -12, which is the last, is equal to -252. Of course, you can just take each number and add them to the last number and so on, right? But when you come across a larger sequence, Gauss-Trick is useful. So make sure we know how to use Gauss-Trick for arithmetic series, which is sum of arithmetic sequence. For 12, we need to find the geometric sum of the first 4 terms. And of course, we can add them together or we can use the equation. So the equation is shown here. A times 1 minus r and raise it to the n plus 1 divided by 1 minus r. So when we plug that in, since we have 4 terms, that will be our n. And our r is the common ratio. So you take 30 divided by 10, you get 3. That's our r. Or we can take 90 divided by 30, we also get a 3. And then our a is our first value here in the sequence. That's 10. So plug that into your calculator and you should have the result. Make sure we know the definition for recurrence. It is a relation that recursively define a sequence where the next term is a function of the previous term. And in C++, we implement recurrence by using a function calling itself. Any question? Almost there. A little bit more to go and we're done. So now we need to find the recurrence relation and the initial conditions for 1, 5, 17, 53, 161, and 485. So in this one, you saw this in the assignment already, right? We would first look at the difference between the terms. So 1 to 5 is 4, right? The difference between 1 and 5 is 4. 17 and 5 is 12. And so after we look at the difference, we would see that there is a common factor. 4 times 3, 12 times 3, 36 times 3, and so on. So 3 is your common factor. So if you take the first term, which is 1, and you multiply it by 3, you get a 3. You take the second term, multiply it by 3, you get a 15, and so on. And you're going to note that it's going to be 2 less than the next term. So we simply take the term, multiply it by the common factor, which is 3, and we notice that it is 2 less than the next term. So 1 times 3 is 3, which is 2 less than 5. So we would plug that into our equation. A of n would be 3 times the previous number, which is 1, right? A times n minus 1 plus the difference, which is 2. So to approach this, you would first find the difference between the terms, then look at that and find the common factor or the common ratio, which is r, in this case 3. Take that common ratio, multiply it by the first term, and see the difference between that and the second term. And that will be your addition here, your D. And that's how you would express it recursively. And the difference between this and what we've seen previously where we use n is that we use n minus 1 here for the a, right? That would say that that will be the previous term times the value and add 2. So if I take 1, okay, times 3 plus 2 gives me 5. Any question with 14? You've seen this. All right, we need to know Fibonacci sequence. We did a lab on Fibonacci. Okay, Fibonacci sequence is a set of numbers that all the values would derive by adding the two prior numbers. So f of n is equal to f of n minus 1 plus f of n minus 2. And depending on where we seed, it would still be the same. So we can seed it with 1 and 0 or 1 and 1. So those values would be the starting point. So if I take 0 plus 1, I get a 1. 1 plus 1, I get a 2. 1 plus 2, I get a 3, and so on. So make sure that we know how to create a Fibonacci sequence. We really focus on Fibonacci when we talk about sequence in the undergrad, because in various classes, you're going to see Fibonacci again and again, right? It's often used in programming because it's easily seen and calculate. Okay. Then we need to know how to put together your graphs and be able to do the matrix. For 16, this is a weighted graph. So when you do the matrix, you would use the weight of your edge, right? And a vector cannot go to itself. So you can have A to A, we'll put 0. A to B, the weight is 2, you will put 2, and so on. So make sure we know how to build out matrix for your weighted graph. And we need to know how to read graphs. Question on this. Okay, I got 10 minutes. 17. This is a directional graph. So we want to be able to traverse starting from vertex F. And so let's say that we want to go from F back to F. So we can say F, E, B, C, D. But so that will be away, right? I'm going to highlight that. And back to F. But we can go F, B, C, D, F. So when it's here, it can come back to F. So you can say F, E, F, B, C, D, F. Because there's two ways. So it goes here and then it comes back. Seek another way and go around. Secondary. I'm going to put that there. Alternately, we can do F, B, F, E, C, D, F, like that. So that's two ways. And then if we need to do any path, that's easy, right? So you can do F, B, C, D, F. question? We would go for the shortest path. So let's say that we need to go from A to F. We would go A, right? So the shortest path means that it travels over the least node. So we can go A, B, C, D, F. So if you look A, B, C, D, F. And that would be the only way, right? Because it's directional. So your goal in the shortest path is to travel over the least vertex. And then the cheapest path, since they are all weighted equal, we don't have any weight on the edge, it will be the same. Sometimes they're the same, sometimes they're not. So if they're weighted, make sure that you sum up all the edges. If they're the lowest, that will be the cheapest. Any question? Okay, so now we are going to look at the graph for 18. We are going to determine the cheapest, shortest path and the simple path. So this is a weighted non-directional graph. And we're going to go from node B to node D. So here we're going to go from B to D. So we can go B, A, C, D, that will give you 9. B, A, E, D, that will give you 12. B, A, G, F, D, that will give you more. So the cheapest path would be B, A, C, D, that will be 9. It is also the shortest path. But the shortest path can it be BAED, assuming that if these weights represent miles, then your cheapest would be here. So it can also be the shortest path would be BAED. Right? Because the shortest path simply just means that it travels over the least number of vertex. The cheapest is where we would consider the weight. I'm going to remove this so it would confuse you less. And then the simple path simply is just not repeating over any vertex. So we would have BACD also. Can it be BAED? Yes. It can also be B, A, G, F, and D. We need to know what a substitution cipher is, and we talked about Caesar cipher. So letter in plain text that replaced by a letter with some fixed number of positions down the alphabet. We substitute it with the number that is, or the letter that is shifted. Okay. So for 20, it gives you the encrypted phrase. And using Caesar cipher, we know that this is the equation. X plus N mod 26. So when you look at this K, right, if you are given a shift value, let's say 7, you would be able to solve it. So how would we go from here to here, right? So how can I determine the shift value? Well, D to K, if you look at D going down to K and you count it, it will be 7. So your N is 7, which is your shift value. We simply count the letters from D to K or I to P and so on. Okay, a few more minutes. For number 21, we need to determine the domain and the range. In the pair, the domain would be the X value and the range would be the Y value. So we list the domain as 1, -2, 3, and 4. Since if it's repeating, we don't list it twice. In the range, we would have 3, 7, -3, and 5. And you can put them in order. You don't have to. That will be domain to range, which is X to Y. And we know that range is dependent on the domain. For 22, we covered this recently. We're given the set 1, 2, 3, 4. We also have each of the criteria where here we would have a pair of 1s, a pair of 2, a pair of 3, and a pair of 4. We can say that those are reflexive. They are exactly the same. X is Y. Then for 23, we did this for our assignment. We have to look at the graph and determine the relation of R. So A, it is itself, A is equal to A, that is reflexive. B, A is equal to B and B is equal to A, so it is symmetric. If A and B is the same value, then it is also reflexive, right? And then C, A is equal to B and B is equal to C. So A is equal to C, it is transitive. So make sure we know the type of relations that can be represented in numbers and graphs. And we need to know how to solve modular arithmetic. 24a, 23 to the third power mod 9. That's simply 23 mod 9 times 23 mod 9 times 23 mod 9 mod 9. So don't forget that mod 9 at the end. So I wrote it out for you there. So if you take 23 mod 9, 23 divided by 9, right? You would have 2 as a quotient, and then the remainder would be 8. So 18, 23, 7, I would say, right? And then you would apply mod 9. So the output is going to be 8. So no matter how you solve it, where you plug it into your calculator this way, or you expand it and plug it into your calculator, you should still get the same result. Okay. For 25, we would do 12 to the fourth power mod 11. That simply is 12 mod 11 times 12 to the third mod 11 mod 11. That should give you 1. So you can solve it this way, or you can solve it this way, which also gives you 1. And then for 26, we have a negative 37 mod 17. So we will break it down to negative 3 times 17 plus 14 for 37, or negative 37. So the format is, or the form of it is, that we would do negative a mod n equal to n minus a mod n. So that will be 17 minus 37 mod 17 is going to be equal to 14. So you need to put it into this form, okay? For 27, the solution for 15 plus 29 mod 2, you can add it in a mod 2, or you can expand it like what we practiced. That will be 15 mod 2 plus 29 mod 2, and then everything mod 2. So 15 mod 2 would give you 1. 29 mod 2 would give you 1. So 1 plus 1 is 2. 2 mod 2 is going to be 0. Okay. Easy. All right. You need to know how to do modular multiplication, just like what we did with addition. We can expand it the same way. 2 times 3 mod 7, which is 6 mod 7, it should give you 6. But if you expand it, that will be 2 mod 7, which is 2. 3 mod 7, which is 3. 2 times 3 is 6. Mod 7 again, you should get a 6. And I know time is up. 29, we need to solve for negative 6 mod 19. Again, we use the negative modular form, right? So that would be 19 minus 6 mod 19, which is 13. And then for 30, we have to use Vigenère to solve. For encryption and decryption. So I did sum up for you for the first few letters. So with Vigenère, recall that we would go use the plain text and cross-reference it with the key. So you're going to go across for C and down for E, which lands you on G. okay? Across for C, and then down to E, which lands on G, and then R and N, across for R, and then go down to N, gives you E. So make sure we know how to use Vigenère to encrypt and decrypt. Okay. And that, my friend, is the end. So thank you so much for a good semester. I am teaching this class again next semester, but online only. We will not do Zoom. We're going to try that out. But if you're looking to take CIS11, which is LC3, I am teaching it in the spring. That class usually fills up pretty good. I am in the winter, I'm doing 18A and 30A. And Python class is transferable to UCR, UCI, UC Davis. And I know we worked on the CSU, so it should be there now too. So you can take Python classes and transfer for programming as well, for computer science, whether you go into data science or computer science general, right? So, and also Java is 18A, which is different than 14A JavaScript, okay? And they are all online classes for the winter. And I hope to see some of you in my future classes. And thank you so much for a good semester. You will hear from me again for other things like final exam and projects reminder and things like that. But from here on out, we will not meet on Zoom again. So thank you and have a good night and see you later. Type your name into the chat for attendance. Take care.